Hi, I am Gurumurthy. I am going to explain about cryptography. Network security is mostly achieved through the use of cryptography. The cryptography, a word with Greek origins, it means secret writing. However, we use the term to refer to the science and art of transforming messages to make them secure and immune to attacks. In this diagram, you can see we can differentiate firewall and cryptography. Firewall, it is used to protect your networks. Cryptography, it is used to protect your transaction. So these are all the key concepts we are going to discuss under cryptography. First one is the cryptography components. The important components are sender, receiver, plain text and cybertext, encryption and decryption algorithm. First one is the plain text. Plain text is the original message before being transformed. That is, plain text is the original message. Cybertext is the after message is transformed. So next one is the encryption algorithm. It is used to transform the plain text into cybertext. And decryption algorithm, it transforms the cybertext back into the plain text. So sender uses the encryption algorithm and receiver uses the decryption algorithm. After that, Alice, Bob and Eve. These are all the important persons. First one is the Alice. Alice is the person who needs to send the secure data. That is, Alice is the actual sender. Bob is the recipient of data. That is, Bob is the actual receiver. Eve. Eve is the persons who somehow disturb the communications between Alice and Bob by intercepting messages to uncover the data or by sending a own destroying message. So Eve is the intruder. So next one is the categories of cryptography. Cryptography is divided into two types. One is the symmetric key algorithm or else secret key, and another one is the asymmetric key or public key algorithm. First one is the symmetric key cryptography. In symmetric key cryptography, the same key is used by both parties. Here, Alice is the sender, Bob is the receiver. So, sender uses this key and encryption algorithm to encrypt the data, and the receiver uses the same key and corresponding decryption algorithm to decrypt the data. That is, Alice uses this key and encryption algorithm to convert into plain text into cybertext. In receiver, again it uses the same key and decryption algorithm to convert into cybertext into the plain text. So as I said, in symmetric key cryptography, the same key is used by the sender for encryption and the receiver for decryption. So the key is shared. Next one is the asymmetric key cryptography. In asymmetric key cryptography, there are two keys. One is the private key and another is the public key. Private key is kept by the receiver and the public key is announced to the public. From this diagram, imagine now Alice wants to send the message to Bob. Now Alice uses the public key to encrypt the message. When the message is received by the Bob uses the private key to decrypt the message. So in this asymmetric key cryptography, the public key is used for encryption, private key is used for decryption. That is, public key is available to the public, private key is available only to an individual. So in symmetric key, we are using shared secret key is used. In asymmetric key, there are two keys are used, public key for encryption, private key for decryption. And comparison between two categories of cryptography. So in symmetric key, we are using shared secret key. Shared key for encryption and the same key used for decryption. In asymmetric key algorithm, we are using two keys, one key for public, another key is private key. Public key used for encryption and private key is used for decryption. So traditional cyber. Traditional cyber is divided into two types. One is the substitution cyber, another one is the transposition cyber. Again, substitution cyber is divided into two types. One is the monoalphabetic, another one is the polyalphabetic. First one is the substitution cyber. In substitution cyber, the one symbol is replaced with the another symbol. In the following example, you can understand The following shows the plain text and its corresponding ciphertext. Is this cyber monoalphabetic? So plain text is the hello, the ciphertext is the KHONR. So what is the solution? Is the ciphertext probably monoalphabetic because both the occurrence of L are encrypted as 0. So when here two L's are available, the two occurrence of two L are encrypted as 0. So it is the monoalphabetic. In the next example, so here the plain text is the hello, ciphertext is the A, B, N, Z, F. The solution is the cipher is not a monoalphabetic because each occurrence of L is encrypted by a different character. First L is encrypted by N, again another L is encrypted by Z. So it is not a monoalphabetic, it is a polyalphabetic substitution cipher. Next important cipher, this shift cipher is sometimes referred to as the Caesar cipher because Julius Caesar used the shift cipher to communicate with his officers. So for this reason, the shift cipher is sometimes referred as the Caesar cipher. So shift cipher, shifting the position of the symbols. The encryption algorithm is shift key characters down. The decryption algorithm is the shift key characters up. In this example, use the shift cipher with the key 15 to decrypt the message. The solution, we decrypt one character at a time. Each character is shifted 15 characters down. So letter H is encrypted to W. That is, H character is shifted 15 characters down to W. So letter E is encrypted to T. L is encrypted to A. Again, next L is also encrypted to A. Finally, the O is encrypted to D. The final ciphertext is WTAAD. Another example, use the shift cipher with the key 15 to decrypt the message WTAAD. The solution, we decrypt one character at a time. So each character is shifted 15 characters up. So W is decrypted to H and the letter T is decrypted to E. The first A is decrypted to L and again next A is decrypted to L and finally D is decrypted to 0. The final plain text is the hello, HELLO. The next cipher is the transposition ciphers. This transposition cipher reorders or permutates the symbols in a block of symbols. In transposition ciphers, there is no substitution of character. Instead, their location change. A character in the first position of plain text may appear in the 10th position of the ciphertext. A character in the 8th position may appear in the first position. In other words, the transposition ciphers reorder the symbols in a block of symbols. Here the sender reorder the plain text is converted into ciphertext block. Again, decryption is reorder the data to convert ciphertext into the plain text. From this example, you can understand about the transposition cipher. Encrypt the message hello my dear using the key shown in the figure. Solution is we first remove the space in the message. We then divide the text into the block of 4 characters. We add the bogus data character Z at the end of the third block. The result is HELLOMAYD EARZ. There we create the 3 block of ciphertext, the ELHLMDOYAZER. Next, using the example, we can decrypt the message ELHLMDOYAZER. The solution, the result is the HELLOMYD EARZ. After removing the bogus character and combining the characters, we get the original message HELLO, hello my dear. This is the basic concept of transposition cipher. That's all about my presentation. Thank you very much.